Good morning, everyone, or good evening, depending on where you're tuned in to this lecture from. My name is Dr. James Mitchell, and welcome back to Science Explained Properly. If you've been following along, we've talked about why stars exist and how the universe built its structure. Today, we're going to zoom in, way in, and talk about something much closer to home: your body. Specifically, what it's actually made of. And I'm going to tell you something that sounds completely absurd, but is absolutely true. You have never actually touched anything in your entire life. Not this desk, not another person, not even yourself. Every surface you think you've touched, every object you think you've held. You've never made contact with any of it, not in the way you think. Now, I know what you're thinking. I can feel this chair I'm sitting in right now. Of course I'm touching it. But here's the thing. What you're feeling isn't contact. It's repulsion. And I understand if repulsion sounds confusing to you now. But by the end of this lecture, you'll understand why solid objects aren't actually solid, why matter is almost entirely empty space, and why the sensation of touch is one of the most elaborate illusions your brain has ever convinced you to believe. So let's begin. Let's start with the obvious. When you touch a table, it feels solid. When you sit in a chair, it supports your weight. When you pick up a book, you can feel its edges, its weight, its texture. Everything in your everyday experience tells you that matter is solid, substantial, real, impenetrable, and in a practical sense, that's true. You can't walk through walls. You can't pass your hand through a table. Objects occupy space, and when two objects try to occupy the same space, they resist each other. So far, so good. But here's where it gets strange. If you could zoom in, really zoom in, to see what matter is actually made of, you'd discover something deeply uncomfortable. There's almost nothing there. Let me explain what I mean by that. Everything around you is made of atoms. Your body, this room, the air you're breathing, all of it. Atoms are the building blocks of matter. You probably learned this in school. But here's what they don't always emphasize. Atoms are almost entirely empty space. Not mostly empty, almost entirely empty. If an atom were the size of a football stadium, the nucleus, the dense center where protons and neutrons live, would be about the size of a marble sitting in the middle of the field. And the electrons, they'd be tiny specks orbiting somewhere up in the nosebleed seats. Everything in between, the entire volume of the stadium, is just empty space. Nothing there. Now scale that back down to reality. Your hand is made of trillions of atoms. Each one is 99.9999% empty space, which means your hand, the thing you're looking at right now, is effectively a cloud of mostly nothing, held together by forces you can't see, occupying a space that's almost entirely void. And yet, it feels solid. So what's going on? Here's the question. If matter is almost entirely empty space, why don't you fall through the floor? Why doesn't your hand pass through the table? If atoms are mostly nothing, why does anything feel solid at all? The answer comes down to forces, specifically electromagnetic repulsion. Let me walk you through it. First, a quick refresher on atoms. An atom has a nucleus at its center, made of protons, and protons are positively charged, and neutrons, which have no charge. Orbiting around said nucleus are electrons, tiny, negatively charged particles. Now, here's the key thing. Electrons are negatively charged and the nucleus is positively charged. Opposite charges attract. That's what holds the atom together. The electrons are constantly being pulled toward the nucleus, but they also have energy. They're moving, in a sense, and that prevents them from collapsing inward. So the atom stays stable. But here's what happens when two atoms get close to each other. As they approach, their electron clouds start to overlap. Remember, electrons are negatively charged. And what happens when you try to push two negatively charged things together? They repel strongly. This is called electromagnetic repulsion, and it's one of the fundamental forces of nature. Like charges repel. So when your hand approaches a table, what's really happening is this. The electrons in the atoms of your hand are getting close to the electrons in the atoms of the table. And those electrons are pushing back, hard. You don't feel the table's surface. You feel the electromagnetic force pushing your hand away. Let me give you an analogy to make electromagnetic repulsion a bit easier to understand. Imagine two powerful magnets with the same poles facing each other, north to north or south to south. When you try to push them together, you feel resistance. The closer you push, stronger the resistance becomes. You can press hard, but there's always a gap, a tiny space between them where the magnetic force pushes back. That's what's happening every time you touch something. There's always a gap. A microscopic one, but it's there. The electrons in your hand never actually make contact with the electrons in the table. They just get close enough that the repulsive force between them becomes strong enough to stop your hand from moving forward. And your brain interprets that resistance as solid. So if you're not actually making contact, what is touch? Touch is electromagnetic repulsion, interpreted by your nervous system. Here's how it works. When you press your hand against a surface, the atoms in your skin are getting very close to the atoms in that surface. The electromagnetic force between them pushes back. That force compresses the tissues in your hand very slightly. That compression triggers nerve endings in your skin, receptors designed to detect mechanical pressure. Those receptors send electrical signals up your nerves to your brain, and your brain interprets those signals as, I'm touching something solid, but you're not touching it. You're feeling the force field around it. Here's another way to think about it. Imagine you're standing in a room filled with incredibly powerful fans, all pointing at you. You can't see the air, but you feel the pressure pushing against you. If you try to walk forward, the air resistance pushes back. The closer you get to the fans, the stronger the force. Eventually, the force is strong enough that you can't move forward anymore. You'd describe that sensation as hitting a wall, even though you never made contact with anything solid. That's essentially what's happening when you touch an object. You're pushing against an invisible force field made of electromagnetic repulsion, and your brain has learned to interpret that as solid. Now, I know this might feel deeply wrong, because your entire life experience tells you that objects are solid. You've spent decades interacting with the world as if matter is substantial, real, impenetrable. And suddenly I'm telling you it's mostly empty space held together by invisible forces. So let me be clear. You're not wrong to feel like things are solid. They are solid in every practical, meaningful sense of the word. The electromagnetic forces holding matter together are incredibly strong. Strong enough to support buildings. Strong enough to hold your bones together. Strong enough that you will never, ever experience atoms passing through each other under normal circumstances. The solidity you feel is real. It's just not what you thought it was. You thought solidity meant stuff packed tightly together. But it actually means forces pushing back hard enough to resist compression. The sensation is the same. The underlying reality is just more interesting. Here's an analogy that might help. Think of a trampoline. When you jump on a trampoline, it feels solid. It supports your weight. But the trampoline isn't a solid surface. It's a fabric stretched tight by springs. When you land on it, the fabric resists because of the tension in the springs. not because the material itself is impenetrable. Matter works the same way. Atoms aren't solid little balls. They're regions of space where electromagnetic forces create resistance. And that resistance is what you interpret as solidity. The trampoline holds you up not because it's solid, but because the forces are balanced. Your chair does the same thing. Let's bring this back to you for a moment. You are made of atoms, trillions and trillions of them, and each one is almost entirely empty space, which means that you are almost entirely empty space. If you could somehow remove all the empty space from your body, collapse all the atoms down so that only the nuclei and electrons remained, with no gaps, your entire body would fit into a space smaller than a grain of sand. All of your being, everything that makes you you, your bones, your organs, your brain, your thoughts, compressed down to something you could barely see with the naked eye. And yet, here you are, taking up space, feeling solid, interacting with the world as though you're made of something substantial. You are. But that substance isn't stuff. It's structure. It's forces, it's electromagnetic fields holding particles in very specific, very stable configurations. Now here's the part that gets even stranger. The nucleus of an atom, the tiny marble in the middle of that stadium, is made of protons and neutrons. But protons and neutrons aren't fundamental. They're made of smaller particles called quarks. And quarks, as far as we can tell, have no size. They're point particles, which means that if you zoom in far enough, even the solid nucleus dissolves into something that's not really there in the way you'd expect. The deeper you look, the less stuff you find. What you find instead are fields, forces, probabilities, patterns of energy. The universe, at its most fundamental level, isn't made of things. It's simply made of interactions. So why does any of this matter? Why does it matter that you've never actually touched anything? Because it changes the way you see the world. Every object you interact with, every surface, every person, everything, is a shimmering cloud of mostly empty space, held together by invisible forces. And yet, it all works. The forces are strong enough. The structure is stable enough. The patterns are consistent enough. Reality doesn't need to be solid to be real. It just needs to be structured. And here's the beautiful part. The same forces that prevent your hand from passing through a table are the forces that hold you together. Electromagnetic repulsion isn't just an inconvenience. It's what allows matter to have shape, form, structure. Without it, atoms would collapse. Chemistry wouldn't exist. Molecules couldn't form. Life wouldn't be possible. So the next time you touch something, or think you're touching it, remember, you're feeling the universe's way of keeping itself organized. You're feeling the electromagnetic force that prevents chaos. You're feeling the boundary between one cloud of particles and another. And your brain, magnificent as it is, takes all of that invisible, abstract physics and turns it into the sensation of a solid world. Let's talk about your brain for a moment. Because your brain is doing something extraordinary here. It's taking raw physical data, electromagnetic forces, nerve signals, pressure gradients, and constructing a coherent, stable experience of the world. It's creating the illusion of solidity, not because it's trying to deceive you, but because solidity is useful. Think about it. If your brain gave you the raw truth every time you touched something, electromagnetic repulsion detected, force magnitude increasing, electron clouds overlapping, you'd go mad. You'd be overwhelmed by information you don't need. So your brain simplifies. It takes that complex electromagnetic interaction and gives you something clean, clear, and immediately useful. This is solid, You can stand on it. Don't try to walk through it. And that works. That's all you need to survive. But now you know the truth underneath. Here's another example. When you look at a red apple, you think you're seeing red. But red doesn't exist in the apple. The apple is reflecting certain wavelengths of light, around 700 nanometers, and absorbing others. Your eyes detect those wavelengths, send signals to your brain, and your brain constructs the experience of red. The apple isn't red. Redness is something your brain creates. Touch works the same way. The table isn't solid. Solidity is something your brain creates. Both are useful fictions. Both help you navigate the world, but they're not the underlying reality. Now, here's where this starts to feel a little philosophical. If solid matter is mostly empty space, and if touching is just electromagnetic repulsion, then what does that say about everything else? It says that the world you experience is a model, not a lie. Not an illusion in the sense of being fake, but a representation. A simplified, useful version of a reality that's far more complex, far more strange, and far less intuitive than your senses suggest. Your brain builds a world you can navigate, a world where objects are solid, where colors exist, where sounds have meaning. But the actual universe, the one described by physics, is far weirder. It's fields and forces, probabilities and particles, waves and interactions. And yet, it all works. The model your brain creates is accurate enough, useful enough, consistent enough. You can live your entire life believing that tables are solid and never encounter a problem. But once you know the truth, you see the world differently. You see the invisible forces holding everything together. You see the space inside matter. You see the elegance of a universe that manages to feel solid without ever actually being solid. Now, before we finish, let me address the obvious question. If matter is mostly empty space, why can't you just pass through it? Why can't you walk through walls? Because the forces are absurdly strong. Electromagnetic repulsion isn't a gentle suggestion. It's one of the fundamental forces of nature, and at the atomic scale, it's incredibly powerful. To push two atoms close enough that their electron clouds actually overlap, close enough to break through that repulsion, you'd need enormous energy. More energy than your body can produce. More energy than you'd ever encounter in daily life. So even though matter is mostly empty space, the forces guarding that space are strong enough to keep everything in place. You're not solid, but you're solid enough, and that's all that matters. All right, that brings us to the end of today's presentation. We started with a simple, uncomfortable claim. You've never actually touched anything. And what we've found is that touch isn't what you thought it was. It's not contact, it's repulsion. Every time you feel a surface, you're feeling the electromagnetic force pushing back against the electrons in your hand. Every time you think you're holding something solid, you're holding a cloud of mostly empty space, structured by invisible forces. And here's the remarkable part. It works. The universe doesn't need matter to be solid for it to behave as though it is. It just needs forces to be strong enough and structure to be stable enough. And that's exactly what we have. So before you go, I want you to think about this. Right now, as you're sitting in your chair, you're not actually touching it. You're hovering, just barely, held up by electromagnetic forces you can't see, supported by a structure that's almost entirely empty, and yet it feels real. Because it is real. Solidity isn't about stuff. It's about forces. And the forces that hold you together, that hold this world together, are some of the strongest, most reliable forces in the universe. You are not made of solid matter. You are made of space, structure, and invisible fields. And somehow that's even more beautiful than the alternative. In the next lecture, we'll shift our focus again. We've talked about stars, structure, and matter. Now we're going to talk about time. Specifically, why does time only move in one direction? Why do we remember the past but not the future? And what does entropy have to do with all of it? But for now, take a moment. Look at your hand. Realize that it's mostly nothing, and marvel at the fact that it works anyway. Thank you for listening. I'll see you in the next lecture.